So now we're going to look at some applications of quadratic functions. So first one is going to be throwing a stone off a cliff. All right, so the person on the edge of a cliff throws a stone so it hits the base, near the base of the cliff. The stone's height, right, in other words, your y, is given after t seconds, so t is your x by this function. The height is equal to negative 16t squared plus 30t plus 200. What's the height of the stone when it's thrown? Okay, so when it's thrown, what's up with time when you throw the stone? So I'm standing here on a cliff. I throw a stone. When I throw it, I want to know the height when I throw it. What's my time at that spot, right when I throw it? 0 seconds. Does that make sense? So right when I throw it, that's when my time starts. 0 seconds, right when I throw it. So we're going to put in 0 in for t, right? T equals 0. So then my y will be, my height will be negative 16, 0 squared, plus 30 times 0, plus 200. But here's the deal. A multiplied by 0 is just 0. So those go away. So then my height, we'll call the height y, h, we'll call it h, that's fine. My height will be 200, what is it, 200, doesn't say, oh, in feet, 200 feet. Seem okay?
Everything goes away except for the 200.
Yep, because you multiply by 0. Anything that has a t in it will go away. That's multiplied by t will go away. Find the vertex. What's up with the vertex? My h is equal to negative b over 2a. So everybody find the h.
That makes it kind of confusing because h stands for height.
Oh, sorry. Right, let's call the h y. Let's heck with that. This is because this is going to be what? Cross out the h and make that y. Make all of h's y. And I'm going to put a little, if it helps, put a little v for the vertex. Is that easier? I don't know. Or is x easier?
Well, when you have more than like x and y, it always gets
I know.
confusing.
All right, so let's do this. Cross this out and instead write y equals negative 16x squared plus 30x plus 200. I know that's why I think I varied off of h last time because of that.
6.
So just rewrite it. Only put in x's for t's instead. Is everyone all right with that? I think everyone will feel better. Just remember on the homework that it might call it t and just make it x. Just remember your x's will be t's.
Oh, you're calling places too.
Yeah. We're converting it over because otherwise, like June pointed out, my h, it gets confusing. It's not height. This is my vertex.
So at this point, the height is no longer t, the height is x.
And the height is y.
Oh, so change the t to a y?
No, the t is time. That's my x. T is x.
Yeah, that's what I said, t is x.
X. And my height, h, is y. My height is y. Time is x. Okay, so everybody find your h. Find the vertex. X for the vertex. Negative b over 2a. What's my b? What's my a? Did you find it yet? Not it yet. And then, what's my A, what's my B, what's my C? Right? What's my A in this problem? What's my B in this problem? What's my C in this problem? Yes, now plug it in here to find the H.
Just write the coordinates in fraction form, so just reduce it.
Oh, don't divide?
Right,
Oh, just swap it, divide.
So divide by 2. So negative 15 over 16.
This is A.
Always equal to those.
Oh, that's about to divide it. To try to get a number.
Yeah, no, it says write the coordinates
Oh,
in
I
fraction
didn't
form.
remember. Oh, okay, I didn't remember. The fraction of the minimum, not the vertex.
Yeah.
Minimum and
Okay,
maximum.
so negative B, negative, my B is 30 over 2 times my A, which is negative 16. So then I'm going to end up with negative 30 over negative 16, or over negative 32, which the negatives will cancel out, and I'll end up with, I can reduce this a little bit, divide both sides, top and bottom, by 2, and I'll get 15 over 16. If you left it as 30 over 32, that's okay too. All right, but it'll help you to do this if you divide top and bottom by 2. Okay, so that's my first one. Now I need to find my,
So you're getting rid of those last negatives because you're dividing by 2?
no, because negative over negative is positive. They cancel out. Here, think of it like this. Negative 30 is really 2 times 3 times 5. And on the bottom, 32 is negative 2 times 2 times 2, 8, 16, 32. So then the negatives will cancel out. 2's will cancel out. I'm left with 3 times 5 on the top. I'm left with 2 times 2 times 2 times 2 on the bottom, 16. Do you remember when we did this?
Yeah, but that's
Earlier
just more
in the
confusing,
week?
I think, than.
How it's on the top and the bottom,
Yeah,
and negative over negative cancels out?
yeah,
2 over 2 cancels out?
yeah. I mean, I'm following you, it's just, I don't know how, but that's okay.
Well, definitely a negative, if you're multiplying divided by a negative, or multiplying, if a negative times a negative, or a negative divided by a negative is a positive.
We're not doing the division, we're just reducing, right?
Well, this is division.
Well, because we're not dividing negative 30 by negative 32, are we?
Yeah, we are. I mean, wait.
So,
But we're going to leave them as fractions. This is negative 30 divided by negative 2. This is 15 divided by 16.
right,
That's what this is. We're going to leave it as a fraction, but that's what this means. So the negatives will go away,
yeah.
because you have a negative divided by a negative. Now I'm going to reduce that a little bit,
Yeah,
and I'm going to say, okay, I'm going to divide this by 2, divide that by 2, and I get, because 2 over 2 is just another form of 1. Right? 2 over 2 is just another form of 1. So you can do it this way and say, oh, 2 over 2 is another form of 1. I can't reduce anything else, so I'm left with 3 times 5 on top and 2 times 2 times 2 times 2 on the bottom. Just like we did with our rational stuff in chapter unit 4, when we simplified those. Okay, so now we're going to, was that last, June, were you here for that part when we simplified those, or was that on Monday? Was that on Monday we did that?
That was on Monday. I remember teaching it to a few students last Friday because
Okay.
they thought the homework was due.
Due,
on
yeah,
Monday.
okay, fair enough. Find the vertex. So write the coordinates in fraction form. That's the H. Now I need to find my K. How do I find my K? I'm going to plug 15 over 16 back into my function. So it's going to be negative 16 times something squared plus 30 times something plus 200. What is that something? 15 over 16 exactly. I don't think I'm going to make you do it in fraction form though. I think it's kind of asking it that much. Well, let's work through this. So I'm going to have negative 16 times 15 times, so I'm going to do the 15 over 16 squared, so it's 15 times 15 over 16 times 16 plus 30 times 15 over 16 plus 20. I just don't see how to get this in fraction form very easily. This is going to be real
It's
pain.
not going to be easy because to add fraction difference have the same common denominator.
Denominator. Yeah, and we
And
can.
that gives you like, if you can, but then it
It's
gives you
over
like
16.
giant numbers. And
Yeah, so I can cancel out one of the 16s here, because we have 16 over 16. This is really 16 over 1. 30 over 1. It might be reasonable. Let's see what we got here. So I'm going to end up, it's good to do it once, I guess, as an exercise. This is negative, and I've got 15. Right, so think the 16ths tell you what they are. The denominators tell you what they are. They're 16ths. The numerators tell you how many of them you have. So think of them like those giant slices, like Costco. You know, everyone's already got those Costco pizzas,
Yeah.
and slice them into 16ths. If you do for a party group, they can slice it into 16ths for you.
Cut, yeah.
So then they're kind of normal size, kind of that way. So think of it as here I have 450 of those little 16th slices. 450. All right. So again, the 16ths tell you what it is. The numerators tell you how many. So think of that Costco pizza. They slice up into 16ths, so then they're about like this. So this is what we're talking about. How many here? So here I have 450 of those slices, those small slices. Here I have 3,200 of those small slices. And here I owe somebody 225 of those small slices. So altogether, how many do I have? I have 450 plus 3,200 of them minus 225 of them. Does that sort of make sense for folks?
Yeah.
So here I'll have 3,200 plus 450 minus 225 of them. I'm just moving around the order, so it's easy for me to get a hold of. And what are they? They're 16ths. So if I do that, I'll end up with 3,450 of them 16ths. That's kind of a lot. So yes, that's a lot of Costco slices of pizza. Can I reduce this? This is a whole bunch of 2's being multiplied on the bottom. That has at least one 2 in it. So everybody take this and divide by 2. I'll get 1725, looks like.
32.25, 34.25.
yeah.
Oh, it's 3425?
Yeah.
Oh, so I did my math wrong. Thank you. I so much wanted that to be a 50. Okay, well that's not, that's it. That's all we got. 'Cause that's not even, so then my vertex is going to be, wow, they're really sort of vicious with this. 15 over 16, comma, 3425 over 16.
Yeah, you're going to grab
That's
something
not
like
very
that.
nice.
Yeah.
Yeah.
I am going to be fine if you do it in decimals. So on the exam, decimals are okay. Do you want to do it again? Do the same thing again, only using decimals? Would people feel comfortable with that so that they get practice with it? Okay, let's do it again using decimals. Okay. So one more time with decimals. Vertex, my h is equal to negative b over 2a, which is negative 30 over 2 times negative 16. It'll end up with positive 30 over 32, which as a decimal, give me like 3 decimal places. What is that? What is 30 divided by 32? Uh, 9375. Okay, great.
She's just showing us how to do it in decimal.
In decimal form. That way you have it for the exam. And then my k would be negative 16 times 0.9375 squared plus 30 times 0.9375 plus 200. Okay, so I'm just going to find that times 0.9375 times 16, negative 14.06, three decimals, that seems fine, plus 30 times 0.9375, 38.125 plus 200. Now if I add those up, plus 200 minus 14.063, I will get 214.062. So I'm okay if you did that instead. And he said, okay, my vertex is going to be vertex 0.93. If you round it, you can do it like that even. 214.062. That's fine. But I would say don't round. Try to give yourself more decimal places on the squaring part, because otherwise this is going to be off a bit. If I rounded it to 0.94, it'd be off quite a bit. And if we rounded it to even 0.938, it's going to be off a little bit. So I would say don't round, here, once you get to your final answer before you round a little bit. You're going to do that. You're going to do it that way. Okay. Next. Does it have a minimum or a maximum of the vertex? What's my A?
Negative 16.
Yeah, so A is negative 16. Oops. All right, so my A is negative 16. So it's going to have a minimum. Is it going to be happy or unhappy? Unhappy. It's going to have a minimum or maximum at the vertex, folks. Someone else. Someone in one of the, not the front row. Jenna? Minimum or maximum?
For negative 16.
Well, here's my A is negative 16, which means my vertex is going to, my parabola is going to look like this. Right, so my vertex would be right there. So it can be a minimum or a maximum.
Maximum.
Yep. Does that make sense? Is that making sense for people? If it's unhappy, then it'll have a maximum. Its unhappiness goes down and down forever. If it were happy, then it would have a minimum, but it would go up and up forever and ever.
Just don't see how you converted the fraction into just the negative 16 and then got the A.
The A was, okay, so,
Oh, you're referring, I gotcha. I see what you're talking about now. It's like, we're not doing the fraction.
no, we're not talking about the vertex. We're
Okay.
talking about A.
Okay.
After how many seconds does the stone reach its maximum height? So what's my vertex again? Vertex, do you want to use the fractions? We'll use the fractions. 15 over 16. And what was it, the other one?
34,
Well, I'm gonna call
25.
that one 214 and just call it that. Or is that what that calls, as they call the other one 214?
Why is it 214?
Because as a decimal, it was 214.06. It's 214. So, use your calculator.
But it was 242.
214. So, everybody do, what would you get for that one? You got 40, what was my fraction? 7 tell me what the fraction was. 3425. I would do 3425 divided by 16. That's basically 214. Everybody with me?
Okay.
And I think it might be 214 and 116. Okay. So we'll call it 214. If you want, we can call it this. 214 and 116. Are people happy with that? No? I'm getting
Well,
like
I'm
a
just
bunch of
confused
shakes.
because we keep jumping back and forth between the numbers.
I understand,
Yeah.
but
The
that's-
forms.
that is the number. It's 214 and 116 is what it is. Because 1/16 is 0.0625 or whatever that is.
Oh, is that equal to 116?
Okay. If you feel better, Eric, you can put in 214 and 116. That's totally fine too. Okay.
Yeah, I mean,
Either one's okay. After how many seconds does it need? So that's my vertex. After how many seconds does it reach the maximum height? So the vertex tells me what my minimum or my maximum. Everybody on board? Okay. Everybody's eyes here for a second. My vertex tells me what my minimum or my maximum is. So in this case, my maximum, I know it goes like this, so it's going to be a maximum. What is the maximum? What's my vertex? What's the maximum? What's the height? What's the output of my vertex? 214. So the maximum height is going to be 214. When does it occur? Well, my x is what? 15 over 16. Does everyone understand? So my time, because remember x is our time, well my time is 15 over 16, 15/16 of a second. My maximum height will be 214 feet. Everybody understand where this is coming from? So that is the part that I need you folks to understand about this application. The interpretation of the vertex. That is pretty much the heaviest we're going to get into applications with quadratics, but it is important that you understand that concept. Is the vertex is either the minimum it gets or the maximum it gets to, and at what time it gets there. So say so here I'm throwing a rock up, it hits its maximum point at 15/16 of a second, and the maximum height of that spot is 214 feet. Good? And then it drops down. Right, I'm throwing a rock, right? Throwing a rock, it goes up, after 15/16 of a second, it has a maximum height of 214, and then it plummets down. So that's what's going on.
The 15/16 is the speed?
It's the time.
Is the time.
There is no speed in this one. It's the time. So it meets it at 15/16 of a second, and we said, rounding to the nearest tenth of a second, what did we say that was again? And we said it's 0.9, is that right? 0.9. 0.93, okay, so and they said tenth of a second, so 0.9 seconds. So they asked us to round to the nearest tenth. Yes? Okay. When does it reach the maximum? Round to the nearest whole foot, 214 feet. Estimate the height of the cliff. Aha. So the height of the cliff. Let's explain that one. Okay. Can everybody see this? Here's the cliff. Here's a little person on top throwing the rock. So I am on top of the cliff. I'm throwing a rock. Right? And I throw it. I release it up here. What's the height of the rock when I release it? We found it earlier. What was the height of the rock when it gets released? 200 feet.
Oh.
Everybody on board? What's the height of the cliff? So from here down to the bottom is 200 feet. What's the height of the cliff? Right here.
So basically,
Minus
what's the
your
height
height.
of the person?
Yeah, minus your height, right?
Minus my height.
Yeah,
200 minus whatever my height is. Is everyone on board?
yeah.
So pick whatever number you think is reasonable for that, but figure out how high you think your person is. Everybody with that? So you can have a range. Pick 5 feet, 6 feet, 7 feet, depending, because the rock's gonna, you're gonna release it up here. Good? Yes? No?
Yeah.
Okay, so do you understand that 200 is my height plus the height of the cliff?
Yeah.
And I'm asking you for the height of the cliff.
Well, it's not actually your height only, it's
The height plus my arm.
plus your arm raised is
Yeah,
higher than your height.
exactly.
Yeah, I
Average
think so.
arm is about.
Right, the height of the person with their arm.
Yeah,
So if
So-
you're saying the average person is 6 feet tall, plus their arm 7 feet, so 200 minus 7 feet, it would be.
Right? So you might say 200 minus
193.
7, you might say 200, but you might be a short person. I'm only 5 feet.
Maybe it's a gnome.
Right, could be a gnome. So just pick a number and figure out what you think is reasonable. So here I'm going to say, I think this person I'm 5 feet tall, so I'm going to say this is 6 feet. Because I'm using me. And I know this whole thing here is 200 feet. So that means that this would be 200 minus 6. So I would say, for me, if it was me, I'd be 194 feet. Because it's not 200 minus 6 feet. But but Eric is going to use 7 or maybe 8 because he might be really tall, right?
cool.
Just so pick whatever number. I'm fine with 193, 192, 195, 196. Any of those things is reasonable. Right? Just
For easy purposes, you can just make it 200 minus
yeah, make
6.
it an even number.
Yeah.
Make it an even number of feet.
It's minus 6.
Or 7,
Yeah. Or,
right?
Yeah.
Right? So 200 feet. So here I'm going to assume person with arm is 6 foot. You could use 7 foot. I'm totally fine with that. You can use 8 foot. You can use 5 feet. Anything in that range is reasonable. Just whatever number you pick there, that's the number you use there. Good? Maybe you want to be a little complicated and use 6.5. That's totally fine too. All right, now use the graphing calculator.
We won't require to have one.
No, Desmos. Desmos. We're going to graph this. Negative 16x squared plus 30x plus 200. Okay, and I'm going to make the settings of the x-axis 0 to 10, 0 to 3, and the y-axis from 0 to 220.
We're going to have to do this on a test? Figure this graphing calculator
Oh,
out?
really? It goes beyond that? Hold on. No. Okay. So this is the arc of it. As they throw it. They're on the cliff. They release it at 200 feet. does it go up or down? Does this have a maximum or a minimum?
That's a max.
How's a maximum? Does everyone see that? What did we say our maximum was? What did we say our maximum was? 214 at 0. So you can see it goes up. So when I release it, does it go up first or does it go just straight down? It goes up and then it comes down. Does that make sense?
Yeah.
We also know because that's a maximum. If it has a maximum, it has to be unhappy. The A was negative, so it has to be unhappy. It should go like that. So he threw it upwards.
Well, even if it has a maximum, you can still throw it down. It's just the vertex would be past the y-axis. It would just kind of be on its way down.
I see what you're saying. Yeah. Yeah, that's a good point.
What do you mean if you pitch it straight down off the
It's,
cliff?
but it went upwards because
Yeah.
because the max
The max is above the
is
starting point,
yeah above the starting.
Oh, we can't see that on the board right now.
Oh, thank you. Starting point. And you can see it went like this. Kind of like that. Doesn't have to be super fancy. But somewhere along that line, those lines, you went down further. That's all good. So what am I going to require on the exam? It'll be basically
No, I mean, are we gonna have to figure out how to plug all that like we just did into Desmos and look at the
No.
graph?
I am going to expect you to give me this. Maybe the height one is thrown. Definitely find the vertex, minimum or max, and then so after how many seconds does it meet its maximum height, and determine the maximum height. So when does the maximum occur, and what is the maximum height? Right. So I expect you to find the vertex. I expect you to be able to interpret the vertex. The vertex means that it reached a maximum height of 214 feet at 0.9 seconds, 0.94 seconds. Know this for exam. Okay, so let's go take a look at the next one. Connect the top corners of the bars in the graph above. Do it. Connect the top corners of the graph above.
No, I don't know what you're asking me to do. What's the top corner? Oh, just